Hi everyone! Today we are going to get familiar with state transition testing. We will quickly go through the theory and then we'll resolve 3 questions from ISTQB sample exam. State transition testing, a black box test technique in which test cases are designed to exercise elements of a state transition model. To be honest, ISTQB tests related to this technique are very simple. Mostly, we don't need to do anything, just analyze the diagram. ISTQB always provides you with diagram. Because of that, the first step is done. Identify states, transitions, and design a state transition diagram. One thing which we need to know is that diagrams normally show only the valid transitions. We will explain on tests how to identify invalid transition. As tests mostly ask about coverage, we need to know that there are 2 common techniques. Coverage is commonly measured as the number of identified states or transitions tested, divided by the total number of identified states or transitions in the test object, normally expressed as percentage. So tests can ask about how many states are covered or transitions mostly. Let's go to the tests. State transition testing is very useful technique on the real projects. Very often you have features which have different business flows. You read business requirements, create a diagram, and design tests according to that. Designing a diagram is the most interesting and the most complex job. But in ISTQB tests, a diagram is already designed for us. And that diagram is full, nothing is missed, so you don't need to find missed transitions or states. That's why tests for this technique are so easy. Let's get familiar with the first test. Pause the video and read the text on your own. As we said before, diagram is designed for us, and we need just to check each statement. First thing which we need to do is to check what exactly test cases cover. Test case number 1. It starts in state S1. Transition action is power on and final state is S2. Test case 2.1. It starts in state S2, transition action is power off, and final state is S1. And same relates to the rest of the test cases. Now we can move to the answers. Let's check answer A. The given test cases cover both valid and invalid transitions in the state transition diagram. We need to remember one thing. State transition diagrams normally show only the valid transitions and exclude the invalid transitions. What would be invalid transaction in this case? Let's imagine that we have test case number 6. It starts in state S1. Transition action is power off and final state is S3. We know that black arrows show valid transitions. And our test case tries to test transitions which don't exist on diagram. That test case would be to try to test invalid transitions. But we have only 5 test cases, and each of them tests valid transitions. Because of that, answer A is incorrect. Let's check the answer B. The given test case represents all possible valid transitions in the state transition diagram. And we already know that it is correct, because we checked this when we tried to check the answer A. But ISTQB is tricky theory. Because of that, we suggest to check all answers anyway. Let's move to the answer C. The given test case represents some of the valid transitions in the state transition diagram. Again, we know that these test cases represent all valid transitions. None of the transition is missing. Because of that, answer C is incorrect. Let's check the last answer. Answer D. The given test case represents pair of transitions in the state transition diagram. This one is strange and tricky, and could confuse us. But S1, S, and S3 can't have pair. There is only one transition. And we don't see any particular logic in the test cases, those are not grouped. Because of that, the answer D is incorrect. Also, answer B is clear and understandable, and we can be sure that it is correct. Because of that, we resolve the first test. Let's check another one. Pause the video and read the question on your own. In this question, we need to find out which of the following sequences of transitions provides the highest level of transition coverage for the model. We know that coverage is commonly measured as the number of identified states or transitions tested, divided by the total number of identified states or transitions in the test object. And we are asked about transition coverage. We need to count how many transitions are in total, and that count how many of those transitions are covered by each answer. Let's begin. Each arrow is a transition, so we have 10 transitions in total. Now we need to check each answer. Let's start from the answer A. From off to wait, and same arrow on the diagram. From wait to off, and same arrow on the diagram. From off to wait, and same arrow on the diagram. As you see, this step has been already performed. Because of this, it doesn't count from the coverage perspective. As we are asked about coverage, this means that we count only unique transitions. If we have tests like that, from wait to off and from off to wait and again, even if you would do it 1,000 times, your coverage will only be 2 transitions out of 10. If you test same thing over and over again, it won't increase your coverage. We hope it is clear. Because of this, we have only one arrow here. Let's check rest of the transitions. From wait to trickle, from trickle to charge, from high to charge, from charge to low. Each of these transitions has a green arrow on the diagram. If we count these arrows, we can see that we have 7 transitions in total covered by this test. The solution for answers B, C, and D is exactly the same. Answer B covers 7 transitions. Answer C covers 6. And the answer D covers 8 transitions. That means that the answer D is correct, as it covers the highest number of transitions. It is a simple question. Let's check one more example of state transitions testing. Pause the video and read the text on your own. We have simple rules and we need to design tests on our own. Our tests cover each transition in the state transition diagram, and each test must start at the beginning state, waiting for customer, and each test ends when a transition arrives at the beginning state. Let's begin. We need to cover all states and all transitions. First of all, we need to check success scenario, from waiting for customer to waiting for fuel type, from waiting for fuel type to waiting for pumping, from waiting for pumping to pumping, from pumping to waiting for customer. Remember, each time when we come to the waiting for customer, our test ends and we can't continue. By this test, we covered all states and 4 transitions, but we still have 3 transitions to cover. Let's design one more test. Our second test will be from waiting for customer to waiting for fuel type, and from waiting for fuel type to waiting for customer. By this test, we covered one more transition. Let's design one more test. From waiting for customer to waiting for fuel type, from waiting for fuel type to waiting for pumping, from waiting for pumping to waiting for customer. By this test, we covered one more transition, cancel or timeout. And we need one more test to cover the last transition, insert invalid credit card. That means that we need only 4 tests to cover all transitions and all system states. As we said, state transitions tests are the simplest. We hope it will help you to resolve the real tests. See you in the next lecture.